Hello everyone, welcome you to Shaurav's classes. And today we are looking at the Azim Premji University M Economics Entrance Paper 2021 and question number 4. Let A and B be two individuals and XA and XB be the amount of a good consumed by them respectively. If one wants to model a situation where individual A is self-centered and individual B is altruistic, when which pair of utility functions best represents the case? Okay, so what do you mean by altruistic? Let me just have a recap of that. Altruistic means basically you care about the consumption of the other individual as well. That means, simply speaking, in terms of utility functions, for agent B, XA should also be there. That means if you look at the options that are given, it can be either option 1 or it can be option 2, because UB is a utility function of individual B and XA is an active component in both the cases. That means individual B cares about the consumption of individual A, and if individual A manages to have higher and higher consumption level, individual B's utility also increases. So it can be either option A and option B, and that has to be combined with the fact that agent A is self-centered. That means he only cares about his consumption level. That means it can be either B or C, where it is only XA, right? So if you just look at the options carefully, both of them come together in option number B, where agent A is your self-centered and agent B is your altruistic, because XA is also a component of the utility function for agent B. Okay, so now moving on to your question number 5 of the Azim Premchand University MA Economics Entrance 2021. Two people, A and B, are expected utility maximizers. A's utility function is given by x square and B's utility function is given by u of b equals to root of x. Both are offered a lottery ticket worth rupees 100 and the prize money of rupees 10,000. The probability of winning the lottery is 0.9%. What Which one of them is going to buy the ticket? So A will buy, B will buy, both will buy, and neither will buy. Okay, so now let's have an understanding of when will the agent buy the ticket. So the probability of winning is basically 0.9%, right? So that is 0.9 divided by 100. So that is 9 by 1000. This is the probability of winning. And initial wealth of the individual is how much? He has to pay rupees 100. So obviously he has that money, right? Rupees 100 for both individuals A and B. Okay. So now what is the initial utility of agent A? Initial utility of A. It will be x square. So that is 100 square. That is 10,000. And what's the initial utility of B? It is root over x. So that is root over 100, which is 10. So this is the initial level of utility before any kind of a gambling begins over here. Now, after taking the lottery, if the expected utility is higher, so this, since they are expected utility maximizers, if the expected utility is higher than the initial utility, then only they will go in for purchasing the lottery. Otherwise, it's pointless. They could have just stayed with their 100 rupees. So, this is the condition for purchasing the lottery. Purchasing the lottery. Okay, so let us denote that P is the probability of winning. Okay, so let us come to the understanding of, let's say, for agent A first. How are we going to go about this? So for agent A, what is the expected utility of agent A? And let me show you once again. Agent A's utility is x squared. That means he's a risk lover basically. So UA is equals to x squared. This is the utility function. So with probability P, we want to see the utility that he will get by winning the lottery. So by winning, he will get 10,000, but he has to pay rupees 100 over here. Okay, this is the trade-off. Plus 1 minus P into utility of 0 because it doesn't earn anything. So that is P into utility of 9900, right? So your P is over here 9 by 1 1000 multiplied by 9900 whole square. Correct? This is what we need to evaluate. So if you just check it out, it will be 9 into 99 square into 100 into 100 divided by 1000. So 3 of the zeros will go. So this will give us something which is definitely higher than 10,000, right? Even if you don't calculate. So for agent A, what do we see? That the expected utility from the lottery is greater than the initial utility that he had. And so agent A will buy the ticket. A will buy the ticket. Okay. Now a similar calculation will follow for agent B. So for agent B, U of B is equals to root of x. So what will be the expected utility? The structure will be the same. P times the utility of 10,000, the amount which he gets minus the amount that he pays, plus 1 minus P U of 0. He gets nothing. So that will be P times utility of 9900, which is 9 by 1000 into root over 9900. So this is basically 9 into root over 99 into 10 divided by 1000, right? So this will be your 9 into 3 root 11 divided by 100. So that is 27 root 11 divided by 100. Correct? So this is what the expression looks like. So now the question is this value your greater than or less than 10? Okay. So this is definitely less than 10 for sure. Therefore, expected utility from lottery is lesser than the initial utility because initially he had 10. So agent B will not buy the ticket. Will not buy the ticket. That's your answer. So let's match it up with the options that we have. It is option A. A will buy the ticket only. Okay. So now moving on to question number 6 of the Azim Premji University M Economics paper 2021. Consider the following two statements about a simple 2% two good exchange economy Where there are no externalities, information is perfect. Neither individuals have any market power and utility functions are well behaved. And the first statement is all Pareto efficient outcomes are achievable through a competitive equilibrium. This is true by the second welfare theorem. And all competitive equilibrium are Pareto efficient. This is also true. This is the first welfare theorem. So you can understand the straightforward answer to this one is option number A, where it states both statement A and statement B are true. Thank you.